Good morning. In this lecture series, we see about a finite element analysis. The first of all, we are discussing the approximate solution of the engineering problem. In this lecture series, we see about the what is the engineering problem we can be solving the different types of aesthetics and mainly the resolving in the finite element analysis. The first we have to introducing the what is the FEA and what is the origination and the evaluation of the FEA. So first of all, the finite element method is a however the revaluation of the numerical techniques and the transformation the engineering analysis and also the continuous shape of the modern innovation across the all the industries. And so first of all, what is the finite element analysis? As we know that is a short form of finite element analysis is called as a FEA is a powerful numerical technique that can be resolving the complex engineering and physical problem that can be subdividing the continuous domain into the smaller and is a simpler part is called as a finite element. So this approach, the transformation, challenging the differential equation into the algebraic equations that computer can resolve the efficiently, enabling the precise analysis of the structure and the heat transfer, fluid dynamics, and countless other applications. So what is the breadth of the FEA? This is like a study in 1940. The Henry Fork framework is the Alexander Henfork introduced the revolutionary lattice framework approaching the solving the elasticity problems, treating the structural components as the interconnected discrete elements. So the breakthrough, the Richard Current developed the pioneering the machine discretization techniques that is useful the triangular elements to resolve the torsion problem and establishing the numerical foundation for the element-based analysis. So the conic term of the formulations is the lining occurred in 1950 to 60. The first of all, the land publications is in 1956 and 1960 they have a terminology establishments. So from this, we have to employ with the first paper exhibit the employing the naming of the finite element analysis method and is establishing the distinct analysis and approach in the structural engineering. And what is the terminology establishing is like the finite element method is a groundbreaking article that would be define the field for the discrete to the come provide the clarity and the direction of the future research. And the mathematical rigor is a John Agrius and the other research contribute the essential mathematical frameworks and the practical algorithm and transforming the FEA from the novel concept and rigorously computational methodology. So first of all, the FEA rise the engineering practice problem and first of all, the industrial adaptation and academic validation. So in the late the 1960 and through the 1970, they witnessed the FEA explosive growth of NASA and the aerospace industry and embodied the method of for the analyze the complex structural problem and previously demand the unsolvable. The commercial and FEA software emerged the decorrelating and access the sophisticated simulations capabilities and enabling the engineering to the tackle real world challenging with the unpredicted accuracy. So the three basic concepts we have to define the aerospace leader and the commercial software and the mathematical foundations. So what are the key advantage of the FEA over the classical method? So it's a geometrical vectorized the details of results and virtual prototype and a multi-physical capability. So we're taking the geometrical versatile. This is handling the irregular shape, the complex boundary, and the irregular geometry that would be impossible to analyzing using the traditional analysis method. The providing the compressive stress, strain, and displacement distribution throughout the entire structure, revealing the critical insight at the every point. In the virtual prototype, the enabling the digital testing optimization and dramatically reducing the need of expansive physical properties and accelerating development cycles. And the multi-physical capabilities that facilitators the coupled simulations across the thermal and fluid and the electromagnetic and the structural domain and also capturing the complex real-world interactions. So these are the milestone of the FEA developments. The first of all, foundations and the expansions and the commercialization and the integral. So each and every step they have to introduce the advantages and the previous versions of the FEA. So, on the visualization of the FEA impact from the before and the theoretical practice. So, before FEA is like a simple and a hard calculation, hand calculation with the significant approximate. But in after FEA, the accurate predicting the structural behavior. And the costly is a physical prototype required for the validation and the efficient design optimization in the virtual environment. The limited ability to analyzing the complex and the comprehensive failure analysis for the preventions. The trial and error design iterations and the data driven the and engineering designs. So these are the summaries of the finite element analysis. The first of all, this we are to the origin and the evaluation. We also know that there is an engineering problem, complex engineering problem, and the mathematical advance and the computing development. While the characteristics, the versatile, the numerical techniques, and applicable to the field problem, modern engineering tool, and the advantage over the analytical methods, the increasing the flexibility, higher efficiency, complex geometry handling, and varied the boundaries conditions and diverse material properties. Thank you.